Now let us see from this example how can we calculate the shortest path. So in this example there is a 5 vertices and there is a 7 edges. Each edge is associated with some weight. That means it is a weighted graph. Now at first here I am considering C is my source vertex. That means from C I want to calculate the shortest path from other vertices. That means the shortest path from C to A, shortest path from C to B, C to B and C to E. So how can we calculate the shortest path? By using the Dijkstra algorithm and applying the approach the Dijkstra algorithms actually follows. Now let us see. So at first mark every node with its minimum distance to node C, that is a source vertex. For node C the distance is 0. Obviously whenever you start from the C, in that case from C to C the value is 0. For the rest of the nodes, as we still don't know what is the minimum distance, it starts begin with the infinity. That means the value of the C is 0 and the other vertex are treated as an infinity in the initial stage. Then we check the neighbors of other current nodes. That means the current node is C and the neighbor of the C is ABD. Then you find out the distance of C to A, C to B and C to D. So what is the distance between C and A? There is an edge between C and A have 1. So the distance of C to A is now 1. C to B here is 7 and C to D is 2. That means initial stage that was infinity and the current node C is relaxed the neighboring node, and the current in such situation the current distance from C to A is 1, C to B is 7, C to D is 2. Now we have to check all the neighbors of the C. Why? Because you have to find out the smallest distance among these three. Here, as if we visit all the neighbors of the C, that means we can say that C is visited, and this visited node is checked by the green mark. So that's why this actually is the status of this graph, that this C nodes is already visited and this C nodes relax the other neighboring vertex, that is ABD. The current distance from C to A is 1, current distance from C to B is 7 and C to D is 2. That's relaxed. Now we need to pick new current node. That node must be the unvisited node with the smallest minimum distance. Now among these three nodes, what will have minimum distance? Obviously the node A have the minimum distance. That's why I'm picking the A nodes as a current node and mark with a red. This is marked with a red. Now we check the neighbor of node A again, ignoring the visiting node. That means we have already visited the C and C is obviously neighbor of A node. But as if C is visited, we can't consider the C node. We just consider the neighboring of A is B only. So in that case, the initial value of the B is 7 and currently A and B is connected with an edge that is a 3. So that's why A node is relaxed the B node by the value 3 plus 1 is a 4. So in that case the current B value is 4. Now again mark A as visited and pick a new current node. So in that case C is already visited, now A is visited. Now we have to pick out a current node which have minimum distance. The minimum distance node here the minimum distance Here which of the minimum distance? The minimum distance is 2. Here the minimum distance is 2. So you have to pick this 2 is the current node. Now again you have to find out the distance between the neighboring node of D. So that is B is the neighboring node and E is the neighboring node. Now what is the distance between B and D? This is 5 and the current value of B is 4. That means 5 plus 2 is 7 is greater than 4. That means B is not relaxed. Here D2 is the value D2E, the value is 7. The cost of this edge is 7 and the initial value of the E is infinity here. Now that's why 7 plus 2 is 9. So 9 less than infinity. So basically D vertex relax the E. Now 2 is visited. Now among between this B and E, we have to find out the minimum distance. So here we have a minimum distance that is a 4. That means we are taking B as a new current node and the neighboring node of B that's not visited, that is only E. That is only E. So here B and E, between B and E have a cost 1 and the current value of E is 9. So 4 plus 1 is 5, that is less than 9. So basically B relax the E. So value of the E is 5. So that means B is visited, now consider E. In that case of the E, all the neighboring vertex is already visited. All the neighboring vertex already visited means E not required to be relaxed the other vertex. So we get the result. That means the distance of A is 1, distance of B is 4, distance of D is 2, distance of E is 5 from the source vertex C. So after calculating all those edges, all those distance, we can get this type of graph. That means if you want to go from C to E, you have to follow this path. If you want to go from C to D, you have to follow via A. So in such a techniques, in such a way, the Dijkstra algorithms actually works. Now, what is the time complexity? Now, if you want to analyze this Dijkstra algorithm, what will be the time complexity? How much time it's actually taken? In a worst case, it's taken actually order of n square. How? Now, if I consider there is a n number of vertices, and if I consider each n, in a worst case, each one vertex relax other n minus one vertex. That means total number of relaxations will be in case of the n vertex n into n minus 1. That's why the worst case time complexity will be the order of n square. So this is the Dijkstra algorithms, and that shows that how the Dijkstra algorithms are used for finding the shortest path from a single source vertex. Hope this particular materials can help you for understanding total greedy methods as well as whatever the applications are used in the greedy methods. From the next video, I will start the dynamic programming.